One type of variable we can experiment with probability on is the discrete random variable. The word discrete means that the variable can only be represented by specific numerical values. It cannot be a category, and the number of possible outcomes must be countable. The word random means that the result we obtain is the result of an experiment. We denote the verbal description of the variable with an uppercase x. Any specific value of x is denoted with a lowercase x. We denote the probability that the variable is x with either the notation, the probability that x equals x, or the probability of x. Suppose a deck of 10 cards consists of one that shows a blue square while the rest are blank. Also suppose that a card is drawn randomly, viewed, and replaced, and then a second card is drawn and viewed. Let x be the number of times the card drawn shows a blue square. Write a discrete probability density function for the random variable x. One way to describe a discrete random variable is to write out the probability of all possible outcomes in a table. The card drawn can show a blue square 0, 1, or 2 times, so the possible values for x are 0, 1, and 2. 9 out of the 10 cards do not show a blue square, so the probability of drawing a card that shows a blue square 0 times is 9 over 10 times 9 over 10 equals 81 over 100. The probability that only the first card drawn shows a blue square is 1 over 10 times 9 over 10 equals 9 over 100. Similarly, the probability that only the second card drawn shows a blue square is 9 over 10 times 1 over 10 equals 9 over 100. So the probability of drawing a card that shows a blue square one time is 9 over 100 plus 9 over 100 equals 18 over 100, or 9 over 50. The probability that both cards drawn show a blue square is 1 over 10 times 1 over 10 equals 1 over 100. Another way we can determine the probability density function for a discrete random variable is by listing the sample space. For this example, consider rolling 2 dice and let x be the total number of dots shown on the 2 dice. First, list the sample space of all possible outcomes. Next to each outcome, write the sum of the two numbers. Now, construct a table of the possible outcomes. In this case, the possible outcomes are all whole numbers between 2 and 12, inclusive. There are 36 possible outcomes. Count how many times each sum appears and divide by 36 to determine the probability. One outcome has a sum of 2, so the probability of a sum of 2 is 1 over 36. Two outcomes have a sum of 3, so the probability of a sum of 3 is 2 out of 36, or 1 over 18. We continue doing this for every sum until the table is complete.